Hi, I'm Ms. Cho, and in this video, we'll expand a parabola from vertex form to standard form. Let's take a look at an example. The most important thing to remember when you're expanding is to follow the order of operations. First, we look for parentheses or groupings. We see we have parentheses here. Next, we're going to look for exponents, and we have them here, so that comes second. Third, we're going to look for multiplication or division, and we see we're multiplying here. So we're going to do that third. And then fourth, we're going to do any addition or subtraction. So let's rewrite this equation. Our term in parentheses is x plus 6, but they're not like terms, so we can't add them. So we have to move on to our next operation, which is squaring. To square this binomial, I'm going to use a box method. So basically, I'm going to take a rectangle and I say I have a side length of x plus 6, and my other side is x plus 6, and I'm going to find the area of this rectangle. X times x is x squared, x times positive 6 is a positive 6x, a 6 times an x is a 6x, and then a 6 times 6 is 36. So I notice I have like terms here, my 6x plus 6x, that gives me 12x. So when I rewrite this, this is x squared plus 12x plus 36. And then I'm just going to recopy all the other operations around it. Now that we've done our exponents, we can move on to multiplication and division. I'm going to use the distributive property to multiply to 4 by every term in this group. So this is 4 times an x squared is a 4x squared, 4 times a 12x is a 48x, and 4 times 36 is 144. I'm going to recopy this minus 11. And I have my like terms of 144 and 11, meaning I just recopy the 4x squared into 48x. 144 minus 11 is 133. So this is my final standard form. I can check this by graphing this on a calculator like Desmos or T83. So this was my original form, and then I'm going to type in my standard form, which I found. So this is 4x squared plus 48x plus 133. And you notice by toggling this on and off that my black parabola in this vertex form and the blue parabola in standard form are exactly on top of each other, so I know that they're right. Let's try a second example. Here I have -3 times x minus 5 squared plus 7. I have parentheses, I see exponents, I see multiplication, and I see addition and subtraction. So to rewrite this, my terms in parentheses, the x minus 5, are not like, so I can't subtract them, so I'm going to move on to finding the exponents. Again, I'm going to draw my area diagram. I'm just going to say my rectangle has a side width of x minus 5, and then x times x is x squared, x times -5 is -5x, -5 times x is -5x, -5 times a -5 is positive 25. So I'm going to rewrite this as x squared, and then my -5x and my -5x make -10x, and then plus 25. Then I'm going to recopy my other operations around it. Once I've done my exponents, I can multiply, so I'm going to use the distributive properties. So -3 times x squared is -3x squared, -3 times a -10x is a positive 30x, and -3 times a positive 25 is -75. I'm going to carry down the plus 7. These are like terms, so then I have -3x squared plus 30x, -75 plus 7 is -68. So now I can check this on Desmos. So this was my vertex form, and I want to see if my standard form is correct. So I had -3x squared plus 30x minus 68. And I can see that my blue standard form is exactly on top of my red vertex form, and I know that I've solved it